Module 5. Document Analysis, Challenges and Techniques. Let's start by defining what a question document actually is. Imagine you're a detective in a crime drama. A piece of paper lands on your desk, and something about it's on your plate. That, my friends, is a question document. In technical terms, it's any document whose authenticity or origin is under scrutiny in a legal setting. This could include handwritten notes, checks, contracts, passports, and even machine-generated documents. When comparing handwriting, we enter a world of individual expression. No two people write exactly alike. Think of your handwriting as a personal dance of the pen. But here's the twist. Even your own handwriting can vary. Factors like mood, age, health, and even writing position can make your dance look a bit different each time. This variation is the heart of the challenge in handwriting analysis. Moving on to the mechanical side of things, printers and photocopiers are like the unsung background artists in the world of documents. They leave subtle marks, patterns, and defects that are unique, much like a fingerprint. These class characteristics refer to features common to a group of machines, like make and model, while individual characteristics are unique to a single machine, like specific wear and tear. Identifying these can point to the origin of a document. Now, let's put on our detective hats and talk about uncovering the sneaky stuff. Alterations, erasures, and obliterations. Document examiners are like the magicians of the forensic world, using an array of techniques to reveal these hidden secrets. They might use chemical methods to reveal ink differences or employ infrared and ultraviolet light to see what's invisible to the naked eye. Sometimes, the answer is as simple as looking at the document through a handheld lens or microscope. Yes, sometimes the tools of the trade are deceptively simple. But not all clues are visible. Indented writings, those ghostly impressions left behind when you write on a pad of paper, are like whispers from the past. They can be coaxed into visibility through side lighting or electrostatic detection methods. Then there's the world of ink and paper comparisons. Think of them as the DNA of the document world. Analyzing their composition can link a document to a specific time or place, but here's the catch. Inks and papers can be incredibly diverse and change over time. This variation can make definitive conclusions a real challenge. Digital Forensics 101. Think of your computer as a busy bee. It buzzes around collecting data from various flowers, inputs like keyboards, mice, or the internet, then stores this nectar in its hive, hard drive, or cloud storage. The bees, processors, convert nectar into honey, usable information. This transformation involves bits and bytes, where a bit is the smallest unit of data, and a byte is like a basket carrying 8 bits. Picture a crime scene. Something's off. There's a computer. It's not just a machine, it's a vault of secrets. How do you ensure this treasure trove of information isn't tampered with? First, don't touch anything. Turning a computer on or off can be like a hurricane through a crime scene. Document everything. Photographs, notes, the works. If you must move the computer, do so with utmost care, ensuring it remains in the same state. Imagine it's a sleeping baby dragon. You don't want to wake it up. Now, let's play detective. Computers hold 2 types of data. Visible, the stuff you see easily, like files and folders, and latent, the hidden or deleted files. It's like looking for clues in a mystery novel. Visible data is the text you read. Latent data is like reading between the lines for hidden meanings. Analyzing this data involves specialized tools and techniques, making sure even the most elusive digital footprints are uncovered. Let's go on a digital footprint expedition. Where has our suspect wandered off to on the internet? The computer's browser history, cache, and cookies are like a diary of internet escapades. Even the most cautious netizen leaves traces. Download folders, chat logs, and email archives. They tell a story. It's like being a cyber archaeologist, digging through layers of digital history. IP addresses are like digital postmarks. They tell you where a piece of internet mail came from. In forensic investigations, these postmarks are crucial. They can link a suspect to a cybercrime, like a breadcrumb trail leading back to the witch's house. Tracing IP addresses involves navigating a maze of networks, but once you find the source, it's like finding the X on a treasure map. Lastly, let's talk about the Swiss Army knife of technology, mobile devices. These gadgets are not just for calls and texts. They're cameras, maps, libraries, and so much more. Each function leaves a trace, a potential goldmine for an investigator. The GPS can show locations, the camera rolls hide photos and videos, and apps keep logs. It's like having a personal assistant who keeps a record of every move you make. Mobile device forensics insights. First off, let's clarify what falls under the umbrella of mobile devices. It's not just your smartphone, although that's the star of the show. Think broader: tablets, smartwatches, portable gaming consoles, and even those GPS devices that insist you take the next exit on a highway over a lake. If it fits in your pocket, or at least a really big one, and does smart things, it's part of this family. Now, onto the juicy part. Why is it trickier to get data from these devices than from a personal computer? Imagine trying to have a conversation in a noisy room versus a quiet library. PCs are like the library, organized, spacious, and relatively straightforward. Mobile devices, however, are the noisy room. They have their own unique operating systems, constantly changing app ecosystems, and varied ways of storing data. It's like trying to understand someone whispering in pig Latin while doing backflips. Speaking of complexities, let's peek into the architecture of these devices. Unlike PCs, mobile devices are designed with portability and efficiency in mind. They're like a Swiss Army knife, compact, multifunctional, but not always easy to take apart. They have integrated circuits, layered components, and an operating system that's more locked down than Fort Knox. This makes extracting data a bit like trying to solve a Rubik's Cube with your feet. Extracting data from mobile devices is a dance of two steps: physical and logical extraction. Physical extraction is like being a detective at a crime scene. You're trying to get everything, including deleted files and hidden nooks and crannies. Logical extraction, on the other hand, is like interviewing witnesses. You get only what the device's operating system willingly gives you, like contacts, call logs, and messages. Each method has its own rhythm and moves, and knowing which dance to do is crucial. The types of evidence you can find on mobile devices are as varied as the apps in an app store. From the classic call logs and texts to the more modern app data and GPS locations, these devices are a goldmine. Imagine each bit of data as a breadcrumb, leading you through the forest of someone's digital life. You might stumble upon incriminating selfies, cryptic notes, or even a digital trail of a midnight pizza order. It's all evidence in the right context. Finally, how do these mobile devices fit into the grand ballet of a digital investigation? They're not just solo performers, they're part of a larger ensemble. In the digital investigation world, mobile devices often provide the missing pieces of a puzzle. They interact with other digital evidence, corroborating or contradicting alibis and timelines. Think of them as the key witnesses in a trial, small but with stories big enough to crack a case wide open. So next time you pick up your phone, remember, it's not just a device, it's a storyteller waiting to be heard.